Good evening, everyone. Uh, I welcome you all to the 10th live session on Bioinformatics NPTEL Algorithms and Applications course. So, in this live lecture, we'll be discussing about ARC programming and importance of developing bioinformatics related algorithms. So, as usual, in the initial part of the lecture, I'll be discussing about the summary of the lectures pertaining to ARC programming and development of computational algorithms. Then we will be solving some sample problems which help us or you to take up the assignments. Then I'll be taking questions from students as well as the portal. Okay, starting with the summary. So this summary will start with the introduction to the programming. So which is a powerful text processing language that allows one to manipulate and analyze text data from various sources. So this programming is designed to work with text files and other text-based data sources. It can read data from files or different pipe commands or command output. So this awk programming is a versatile tool for text processing and data analysis that is widely used in Unix or Linux environments. So this has a wide range of built-in functions and operators that allows one to perform a complex data pre-processing task with ease. So these functions include string manipulation, math functions, data conversions, and many more. One can also define own functions in awk to perform a custom operations. Next is we know how regular expressions are powerful tool for searching and replacing text. This awk programming supports regular expressions as well, which allows one to search for patterns in the text data and allows them to replace these with the other text. So this makes awk a powerful tool for text processing and data analysis. And next is these awk programs are structured around the patterns and actions. A pattern specifies a condition that must be met for the action to be executed. An action here is a sequence of commands that are executed if the pattern is matched. So this allows one to selectively process the data based on the specific criteria. A pattern in awk program specifies a condition that must be met for the action to be executed. Patterns can be based on regular expressions, string matching, or other criteria. So this allows you to selectively process the data based on specific criteria. Next is about the action. So an action in our program is a sequence of commands that are executed if the pattern is matched. These actions can include reading, writing data, or performing calculations and many more. Next is the awk, which provides a wide range of built-in variables that we can use in our programs. So these variables include NR, which stands for current record number, NF, which stands for number of fields in the current record, FS, which stands for the field separator, and more. And here also one can define their own variables to store and to analyze the data. And the last one is this is awk programming can be used on the command line and within a script file. So to run an awk program from the script file, you can save the program to a file with a .awk extension and then run it using the awk command. So this allows you to automate the complex data pre-processing task and integrate awk with the other tools and workflows. So overall, this is a versatile tool for text processing and data analysis. So moving forward, what can we do with the awk programming? So we still now we have discussed this is a powerful text processing language which has wide range of applications related to manipulating and analyzing text. So first is the search and replace text. Awk provides powerful regular expression support which allows one to search for a specific patterns in the text data and replace them with the other text. This can be useful for tasks such as finding and replacing specific words or phrases in a document. Next is extract data from files. Awk allows one to extract specific data from files based on various criteria such as column or row numbers or based on the field delimiters or regular expression patterns. So this can be useful for tasks such as extracting specific columns from a CSV file or extracting data from log files. Next is transforming data. So Awk allows you to perform a wide range of data transformations such as converting text to uppercase or lowercase, removing or adding characters, or reformatting text data into different structure. This can be useful for tasks such as data cleaning or preparation. Next is aggregate data. This programming allows to aggregate data based on various criteria such as grouping data by specific columns or summarizing data based on specific conditions. This can be useful for tasks such as calculating summary statistics or generating reports. Next, it also helps in processing structured data. So this programming supports processing structured data such as data in CSV format or JSON format or XML format. So this processing allows one to manipulate and analyze structured data using talks, built-in functions and operators. Next is to automate this data pre-processing task. So this programming language can be used in combination with other unique tools such as grep, set and cut to automate the complex data pre-processing task. So this can be useful for tasks such as data integration or ETL. ETL means extract, transform and load processes. So overall, this is a versatile tool for text processing and data analysis, and its built-in functions, regular expression support and flexible data pre-processing capabilities make it popular choice among Unix and Linux users. Okay, now we'll be learning about how does the uh, basic syntax of it looks. So awk is a command line tool and it's commonly used for parsing and transforming structured data such as CSV or log files. So here in the first line I am showing a basic syntax of awk, so which include awk followed by pattern, then action and then the file name. So in this syntax, pattern specifies a regular expression or condition that matches the lines of the file, and action specifies the action to be taken on the matched lines. So this awk programming uses various other symbols to perform different operations during the text processing and data manipulation. So here again we'll start discussing some of them along with their meanings and example codes. First are curly braces. So these are used to enclose awk command or statements. These curly braces are used to define the beginning and end of a block of code. So given in this command, the curly braces are used to define a block of code that prints the first and second fields of each line in the file.txt. So we are using curly braces to give awk commands or awk statements. Next is the forward slashes. So these forward slashes are used to define regular expressions or patterns in awk. They are used to search for or match specific text file. So in this command, the forward slashes are used to define the pattern. So here the pattern, the name itself is a pattern again, which then is used to search for the lines that contain this pattern in the file.txt. Next is the dollar sign. This dollar sign is used to reference a specific field or column in a awk. It is used to access or manipulate data in specific column or field of a file. So if you see in this command, the dollar sign is used to reference the first field of each line in the file, and the output what we get is the first field of each line. Next is the double equals to sign. So this double equals to sign is used to test for equality in awk. It is used to compare two values or expression and returns true if they are equal. So in this command, if you see, the double equal sign is used to compare the first field of each line in the file, and now here we are comparing with the string hello, and then the command prints lines where first field is equal to hello. Next is dash f. So the dash f is used to specify the field separator in awk. It is used to set the delimiters used to separate fields or columns in a file. So when we take an CSV file, which stands for comma separated file, the f value is kept for comma. So when we take a TSV file, which is a tab separated file, the delimiter value is set to tab. So if you see in this last command, the dash f is used to set the field separator as comma, because at the end if you see we are reading a file.csv, a CSV file, a comma separated file, and in the awk commands we are using print $1 and $2, which specifies first and second fields of each line in the file. Yeah, these are just a few examples of the symbols used in awk and their meanings. There are many more symbols and operators available in awk that can be used for various data manipulation tasks. Next, I'll be discussing some of the one-liners. Just give me a second. First one, we'll be talking about printing the first column of a CSV file. So first, we use awk awk command followed by the dash of option, which specifies the field separator. So here the field separator is kept as a comma because we are using a CSV file. Then we use curly braces to give the awk commands, where print $1 specifies the print the first field of each line. Similarly, if you see in the second one, we have given $1 and $3 in the awk commands, so which tells us to print, so it will print first column and the third column. Okay, next we'll be checking about the word matching. So in this command, the error is a slash error. Slash is a regular expression that matches lines containing the word error and this print, which is a command again. So it is telling awk programming to print whatever is matched in the previous step, to print those slides that lines that have the regular expression error. Next is to calculate a sum. So now we are handling an TSV file. So once you see, since the file format has been changed, the delimiter is also changed to T, tab separator. So here -f/t specifies the field separator as tab, and now command. So in the curly braces we are giving sum equals to plus $2. So which is telling to add the second field of each line to a running total. So what is its mean is sum equals to sum plus second value, second field of that line. What does this command mean? And then once this running is done, so end command. So once this is end, this print sum specifies the print the total at the end of the file processing. So end and print sum specifies the print the total at the end of the file processing. Next is replacing. So here I want to replace the occurrences of apple with orange. So where I use gsub apple and orange, which specifies to replace all occurrences of apple with orange in each line. And then final print specifies to print the modified lines. Next I'll be discussing about some of the most commonly used symbols in awk along with their meanings and examples. First one is $n, which refers to the nth field in a record, where a field is a section of record separated by a delimiter. So what if we don't define a delimiter? So the default delimiter is a white space. So the command here prints the first and second fields of each line in the file file.txt. Next is the NR, which refers to the current record number, that is line number. So the command here prints the line number and the full record of each line in the file. And next is NF, here, which refers to the number of fields in the current record. The given command under NF prints the number of fields and the full record of each line in the file. Next is begin. So this comes a special pattern that is executed before processing any input records. So this command, what you see, it prints start processing before printing each line. So before printing each line, you see a regular expression print start processing. Next is a end. So this is a special pattern that is executed after processing all input records. Similarly, the purpose of end we have seen in the previous example as well. Next is the FS, which refers to the field separator used to split records into fields. Next is OFS, which refers to the output field separator used to separate fields when printing output. So in both the cases, the default field separator that awk program uses is the white spaces. Next is a pattern. So a pattern that matches record that contain a specific pattern that is given in the format shown. So finally $0, which refers to the entire record or entire line. So which if you see here, when we read a text file, print $O command prints each line of the file, so all the lines. Yeah, before moving forward, I have some set of questions. You can answer these questions using the chat box. Starting with the first one, What is the default field separator in awk programming? I hope I'm audible. So the question here states for what is the default field separator in awk? Just a second. Yeah, it's a. Sorry for the mistake delay. So it's a. So we have mentioned the default separators in the case of FS or OFS is given as a white space. Next one. What is the syntax to print a specified field in awk? You guys remember that we have discussed about the dollar sign which is used to reference. So when we are using a dollar sign, what is the correct way? Yeah, here B is the correct way. So print dollar one will give the first field. Print dollar zero will give all the fields like that. Okay, moving forward to the third one. Which of the following is an awk inbuilt variable? So yeah, I request everyone to answer whether it's right or wrong. So your answers will help for more discussion. I'm audible, right? Yeah. Sorry for the confusion in the last slide. Okay, we'll start our problems from here. So what does the awk command end do? So whether the end is used to specify a pattern to match, or whether it executes a command before processing input, or it executes a command after processing input, or which dominates the awk programming. Okay. Okay. For now I have got some answers. Let's see what is the correct answer. It executes a command after processing the input. If you remember, we have calculated a sum of the fields, and then once this sum calculation of sum is done from the all the fields, we printed the total sum using the end print command. So end is used to execute a command after processing an input. So consider we are having a for loop which constantly updates a total value, and once this for loop is terminated, uh, so we give a end command, end curly braces a command that is to print the total one, so it will print the total value outside. Okay, uh, moving on to the next one. What is the syntax to select lines that match a pattern in awk? How do you specify the pattern? It's simple. What is the format to specify a pattern to match? Yeah, the way we specify the pattern is in the A. We don't use a dollar symbol here because dollar symbol is part of the awk commands. So dollar symbol will be only in the curly braces, and that too dollar symbol is used to specify the fields. Next is, how can you print last field of each line of input in awk? Remember, we are talking about some symbols like NR, NF. Yeah, you people are right. It's option B. Print dollar specifies the field. NF specifies the number of field. So if we have 5 fields, the NF holds the value of 5. So this command will become print dollar 5. So we are printing the last field of each line. Okay, this is the last question. Which of the following awk commands is used to specify the input field separator? Yeah, your answers are correct. Yeah, it's A. FS. FS stands for field separator, and OFS stands for output field separator. Okay, I am done with the introduction of the awk. After this, I'll be discussing summary about development of algorithms. So to start with, why development of algorithms is important in bioinformatics? The development of algorithms is critical in bioinformatics because It allows researchers to analyze and interpret vast amounts of biological data more efficiently and accurately. So, with the advent of high throughput technologies like next generation sequencing, that is NGS, it has become more possible to generate enormous amounts of genomic, transcriptomic, proteomic, and metabolomic data. But analyzing this data presents a significant challenge. So, here algorithms play a crucial role in bioinformatics because they enable researchers to process, analyze, and interpret large and complex biological datasets. These algorithms can be used to identify patterns and relationships within the data and to infer biological function and predict the impact of genetic variations on biological systems. For examples, algorithms can be used to align the sequences, assemble genomes, predict protein structure and functions, and to identify disease causing mutations and to analyze gene expression patterns. So, without these algorithms or computational methods, it would be difficult, if not impossible, it would be difficult to extract the meaningful insights from massive amounts of biological data generated by modern technologies. To summarize, the development of algorithms is essential in bioinformatics because it allows researchers to analyze and interpret biological data in a more efficient way and in an accurate manner as well, leading to new discoveries and advancements in understanding. So, next I'll be discussing what are the steps involved in developing a bioinformatics algorithm. The first step in developing bioinformatics algorithm is to define a problem that algorithm is meant to solve. This involves understanding a biological question or hypothesis that needs to be answered by identifying the relevant data sources. So defining the scope of a project is also essential as it helps to ensure that algorithm is focused and that the results are relevant to the problem at hand. Once problem has been defined, the next step is to gather the necessary data for the project. So this can involve collecting raw data from various sources such as sequencing data, gene expression data, protein interaction data, and other types of biological data. The data should be collected in a format that it is compatible with the algorithm and should be of sufficient quantity to produce the accurate results. Here the data has to be checked for the non-redundancy data because sometimes redundancy may mislead the model predictions. So after the data has been collected, it needs to be pre-processed to make it suitable for analysis. So this may involve cleaning the data, filtering out the noise or errors, and transforming the data into suitable format for analysis. The data pre-processing step is critical as it helps to ensure that the data is accurate, consistent, and free of artifacts that could affect the results of the algorithm. Once the data has been pre-processed, the next step is to develop the algorithm itself. This may involve selecting an appropriate algorithmic approach, implementing this algorithm using a programming language or a software tool. So depending on the complexity of the problem and the algorithmic approach, this step can take a significant amount of time and effort. Next step is validate the algorithm. After the algorithm has been developed, it needs to be validated to ensure that it produces accurate results. So this may involve comparing the algorithm results to those obtained by other methods or using experimental data to test the algorithm's predictions. So this validation is an essential step as it helps to ensure that algorithm is robust, accurate, and reliable. Next is document and dissemination of the algorithm. In summary, the development of bioinformatics algorithm involves multiple steps from defining the problem to disseminating the algorithm to broader scientific community. Each step is critical and requires careful attention to detail and to ensure that algorithm produce an accurate and reliable results that can be used to advance our understanding of biological systems. Okay, here again, the, I have only one question. So, why is the development of algorithms is important in bioinformatics? So, why is the development of algorithms important in bioinformatics? Yeah, answer this question which is in screen. Okay, no other answers except answer D. Yes, D is the correct. So, the development of algorithms is important in bioinformatics for has many reasons, which includes algorithms can help analyze a large amounts of biological data quickly and accurately. These algorithms can also identify patterns and relationships in biological data that may not be apparent to humans. That is, these algorithms can detect patterns and relationships in data that might be difficult for humans to spot. By identifying these patterns, algorithms can help researchers uncover new insights and develop new hypotheses. These algorithms can help predict the structure and function of proteins and other biological molecules. So, therefore, the development of algorithms is crucial in bioinformatics and plays a significant role in advancing our understanding of biological systems. Moving forward to the introduction to machine learning. Machine learning is a field of study that involves developing algorithms and statistical models that enable computer systems to learn and improve their performance on specific tasks with experience. Unlike traditional programming, where explicit instructions are given to the computer system to carry out a task, in machine learning, the system learns from the data and experiences to perform a task more accurately and efficiently over time. ML algorithms use statistical techniques to learn from data or identify patterns or make predictions or decisions based on that. So, this learning process involves identifying relevant features, selecting a suitable model or algorithm, and optimizing it to minimize errors and improve performance. The more data, the more system learns from, the more accurate and reliable its predictions become. Machine learning is a subset of artificial intelligence, which refers to the broader field of creating intelligent systems that can perceive, reason, learn, and act like humans. Artificial intelligence encompasses a range of technologies including robotics, natural language processing, computer vision, in addition to machine learning. Machine learning has numerous applications along various industries, including healthcare, finance, e-commerce, and many more. In healthcare, machine learning is used to analyze the patient data and predict the disease outcomes. While in finance, it is used to detect the fraud and make investment decisions. Yeah, coming to the types of machine learning, the first one is supervised learning, which involves training a machine learning model on labeled data where the input and outputs are known. The algorithm learns from this labeled data to make predictions on a new and unseen data. The goal of supervised learning is to map functions from input variable to output variable by minimizing the error between the predicted and actual output values. So the major goal of a supervised learning is to generate a function, that is f of x equals to y, to develop this and apply this to a new and unseen data. The examples of supervised learning are classification and regression problems. So coming to classification problem, suppose you have a data set of emails and you want to classify them as spam or not. So then you would provide a machine learning algorithm with a labeled data set of emails where correct classification is known. So then the algorithm would learn to predict whether a new email is spam or not by identifying the patterns and features in the data. Next example of supervised learning is regression problems. So if you want to predict the real value, for example, if you want to predict the price of a house based on its size, location, or number of bedrooms. Next is the unsupervised learning. So unsupervised learning involves training a machine learning model on unlabeled data where outputs are not known. So in unsupervised learning, the algorithms learn to identify the patterns and groupings in the data to extract useful information without any specific guidance or feedback. Clustering and dimensionality reduction are the two subclasses or two subtypes in unsupervised learning. Third one is the semi-supervised learning. So involves a training a machine learning model on a combination of labeled and unlabeled data. So here the algorithm learns from both labeled and unlabeled data to make predictions on new and unseen data. Here is speech recognition and image classification are the subtypes. And the final type is the reinforcement learning, so which involves training a machine learning model to learn from trial and error to maximize a reward signal. The algorithm learns to take actions in an environment to maximize the cumulative reward over the time. So in bioinformatics algorithm development, the two main classes are used is supervised and unsupervised only. So here we'll be discussing more about them. So types of supervised learning is classification, where the goal is to predict the categorical output variable. So in the classification problems, the algorithm learns to classify input data into one of the predefined categories, like whether the email could be spam or not. Or next, if we want to classify them, we have a set of images of a handwritten digits, and you want to classify them into their respectable numerical values. Next is a regression, the where the goal is to predict continuous output variable. In regression problems, the algorithm learns to predict a numerical value based on the input features. Next is the type of unsupervised learning. So clustering is the first one. Clustering is a type of unsupervised learning where the goal is to group similar data points together. In clustering problems, the algorithm learns to identify patterns and relationships in the data without any specific guidance or feedback. Next is the dimensionality reduction. So, dimensionality reduction is a type of unsupervised learning where the goal is to reduce number of features in the data while preserving as much information as possible. In dimensionality reduction problems, the algorithm learns to identify the most important features that captures the most variation in the data. Okay, this is the basic intro. In the next class, we'll be detailedly discussing about these things. Okay, here I have some of the questions. So, starting with the first one, what will be the goal of a machine learning? So here we are doing the first one. So what is the given the from the given options? What is the goal of a machine learning? No answer. Or whether this can be helpful to write programs that can solve any problems, or machine learning enables machines to learn from the data and improve their performance over time, or to automate all human jobs, or to replace human decision making with the automated decision making. So the goal itself is present in the name machine learning. So which is related to enable machines. The goal of machine learning is to enable machines to learn from the data and improve their performance over time. So this involves training algorithms to recognize patterns in data and make prediction or decisions based on that data. Okay, next moving forward, what are the two main types of machine learning models or problems? Supervised, unsupervised, classification and regression, deep learning and reinforcement learning, decision trees and random forest. Okay, So this answer B is for the second one or the first one? Okay, let's see. Yeah, the two main types of machine learning problems are supervised and unsupervised learning problems. So classification and regression will come under supervised category. Okay, moving on to the third one. So which type of machine learning problems involves predicting a categorical variable such as whether an email is spam or not? Yes, it is a classification. So which type of machine learning problem involves identifying groups of similar data points? So we are doing the fourth one. Yes, fourth one is C again. It's a clustering. So clustering involves grouping the similar data points together and having clusters such that having similar ones within the cluster and having no similarity among the clusters. Okay, question 5. So which type of machine learning problem involves predicting a continuous value such as price of a house? No answers to the fifth one. So it is a regression problem. So regression problem only deals with the predicting a continuous value or a real value problems. Okay, I'm done with my summary. Now I'll be moving for the problem solving session for today. So the first one is, what is the command to print column 6 and 4 from a file data 1 and to a result 1? Yeah, answer the first question. So what is the command in the given options? What is the command to print column 6 and column 4 from file data 1 to result 1? Okay, I've got an answer. Yes. A. One more answer. B. Yeah, here the question tells us to print column 6 and 4. So in the A or command, we use $6 and $4 to extract. And how to write? So we use this greater than symbol to write a file. So that is the only difference between option A and option B. So here the right answer is option B. So whatever the print of column 6 and column 4 from data 1 file will be diverted to result 1 file only if we use that the greater than symbol. Okay, moving on to the next one. So what is the command to print sixth and the last column from file data1.txt and again write it to result1.txt? So this greater than symbol is kind of a pipe command. So which pipes output of before statement to a next statement. Okay, B. Yeah, this is B. So here last column. So last column is denoted by $NF. So where NF stands for number of fields given in the data.txt. So next is the third one. So what is the command to print alternate lines? Yeah. Here NR represents a record number, current record number. Yeah, option C is the correct, where this gives the reminder, and the print statement only works when the reminder value is 1, not 0. Okay, next is the fourth one. Which of the following is an real value prediction problem in bioinformatics? Which of the following is a real value prediction problem in bioinformatics? Okay, different answers. D, B, B. Yeah, let's see the answer. Yeah, prediction of stabilizing and destabilizing mutations is again a classifying problem. So you're putting a mutant into whether it is stabilizing mutant or a destabilizing mutant. But fold rate is the value prediction where you'll calculate the free energy of folding or Gibbs free energy of folding or Gibbs free energy of unfolding here. Moving on to the fifth one. In printf, which letter is used to represent the format for strings? Yeah, this is a quite easier one. Yeah, this is a simple one. Yes. So, what are the best measures for assessing the performance of a real value prediction method? You, I know this. I didn't. We didn't enter into this part. But if anyone has the knowledge of machine learning models and how do we validate, so this validation part we'll be taking up in the next class along with a detailed tutorial on Veka. Yeah, it is D, where mean, absolute error, and correlation are the ones that used to assess the performance of a regression based model, whereas sensitivity, specificity, ROC, accuracy are used for the a classification problem. Next, if the correlation between the two data sets A and B is +1, then what does the following stand true? Yeah. So when we see a value of 1, we see they are directly correlated. So we are doing the eighth one. Which of the following is a classification problem in bioinformatics? Okay, I see again different answers. So when we check with the options provided, the first one is prediction of binding affinity. Second one is prediction of solvent accessibility. So here binding affinity and solvent accessibility are kind of a real values what we are predicting, like okay, binding affinity of -4 kilocal per mole or -5 kilocal per mole, or solvent accessibility of 900 Armstrong square or 800 Armstrong square. When we see option C here, identification of binding site residues. So given a stretch of sequences, you tell this could be a binding site residue, this may not be a binding site residue. So here, identification of binding site residue is the classification problem in bioinformatics. Others are not. Yeah, this is the last one for today. Yeah, I'm done for with this. I'm done for today. If you have any questions, please ask or mention it in the chat box. Yeah, it is discovered by Alfred, Peter Weinberg, and Brian Kernighan. Yeah, that's all for today. I can take up any questions if you guys have. If no questions, Thank you for attending the session. See you on next Monday. Next Monday will be on Weka programming, where we'll be discussing the concepts of machine learning, and I'll also demonstrate how to use Weka for a machine learning model development and validation. Okay, I think no other questions. I'll stop it here.